Okay, let's tell people that we are live and let's check out. Oh, it's actually day 4. I need to edit this. Day 4. Let me just fix this as well. Day 4. And let's put this in our Discord as well. And maybe we put it in the C# Discord. Okay, so that's all the maybe Twitter. Let's put it on Twitter. Boom, and Twitter. So that's all the websites done. Let's check out Advent of Code today. Day 4, giant squid. Let's see. You're already almost 1.5 kilometers, almost a mile, below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo. Yeah, that's always my first assumption. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random and the chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. The submarine has a bingo subsystem to help passengers, currently you and the giant squid, pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. Let's see, after the first 5 numbers are drawn, there are no winners, but the boards are marked as followed, shown here adjacent to each other to save space. After the next 6 numbers are drawn, there are still no winners. Finally, 24 is drawn. At this point, the third board wins because it has at least one complete row or column of marked numbers. In this case, the entire top row is marked. Yep. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won, 24, to get the final score. Okay. To guarantee victory against a giant squid, figure out which board will win first. What will your final score be if you choose that board? Okay. Okay, that's pretty straightforward. So as always, parsing the data will be a challenge. So we will first have a single row with all the numbers. And then we have split by new lines. We will have the boards, which are then positioned. So it's a fixed width formatting. I don't think I've written something for that yet, but yeah, we might as well make something for that. So let's do that. So we take input split by, and then we do double new line. So var parts is this. And then we have var sequence is parts 0 dot split. I need to call toList on this. toList part 0 dot split. And we split this by comma as in 32s. So now we have the numbers that are drawn, and now we can take the boards, which will be the other ones, and we split those by number and then by space and remove empty lines. So let me see. So we can do parts that skip 1 dot select x split n. So the new line, this will be the boards split by lines, right? So this will be an IEnumerable string array, and then we need to split those by space, and then we do string split options, remove empty entries, string split options, remove empty entries, and then we do as int 32s to list. So we have var boards is this, and this will be a list of int. Okay, like that. Okay, am I correct? This one. Oh, there needs to be a toList in here as well. toList. Okay. So now we have a list of list. So the first list are the boards, the second, and within that are a list of rows, and within that are a list of numbers for the individual numbers. So that's okay. And then we need to keep track. Let me see. Because we need to keep track of the rows and columns. So let me just think about that. Because I think we can have like a variable for a match count. We can have that on the, yeah, okay. This int32s, let's just make sure we do a new here. And we do, so this will be the values. No, values. We can do a new here. Values equals this. And then we can have a match count. Match count 0. So we can keep track how many of those match, and we can do the same for the rows. So let's see, we can do new rows, this. We can have like a dictionary int column match count. Like that. I think this would be enough to get started. So now we can loop through all the boards. So we can do for, will this return the list? Yes. And I is 0, I smaller than sequence plus I. Dot length count. So we can take each number here and then check it off. I'm just thinking if it's efficient, because each number can only occur once in the board. If we need to have a lookup for each number, so that we can quickly check where it resides, I think that might be smart. So we can have lookup is new dictionary int row int col, like that. So what we can do now is for each var board in boards, for each var row in board dot rows, for each var val in row dot values. Now we can do board dot column lookup. Add. We need to have indexes here. Int row num is 0. Row num smaller than board dot rows dot count. Row num like that. And you can have var row is board dot rows row num. And do the same for the columns. For int col num is 0, col num smaller than row dot values dot count col num like that. And now we can add a val is row dot values col num. And we can add val, comma, and this will be row num, comma, col num. So now we have a lookup to see if a board contains a value, and if so, where, so we don't have to scan the board every time. So we pre-built an index to quickly check all of this. So now we can do for each var board in boards. We probably also do the match count. Let's see, the column match count. I can do this for the row as well. So we can do, I actually should do that once for each board, right? Row num board, yeah. So we can do if row num is 0, we do board dot column match count. Col num is 0. So we init that as well. So then we can just increment it. Okay, so we do, and they already said it would be a 5 by 5 grid. So let's just const int col count is 5, const int row count is 5. So we can target those counts to see if this matches the total column count. Then we actually this is probably the row match count for a column. Well, it doesn't matter. Okay, so here we try if board dot try get value. Now lookup try get value. If I can type. Try get value. Val is sequence I. Come on. Val out var index. This board has it. Then we can do board dot rows index dot row. We can increment this one. Let's see, property in match count. It's just an int, right? Am I crazy? Can it be assigned to its reader? I need to make a... Okay, let's just make a class out of this quickly. Public class board. And we'll have a list of list int rows public, and we have this one, that's a column match count. Actually, I can do this for the row as well. You can just call this row match count. Pom 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 pom. I'm just thinking, because I need to know which ones are marked and which aren't. So I can just, I need to keep track of which ones have hit. Pom, 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 pom. Let me think. Because that's just a multi-dimensional index, so we can see, yeah. So let's just say we have int row, int col as a key, and then bool if it matches, and they can have a. Oh yeah, you still need to have the row and the col match count to make it easier. So you keep track of all the matches in here, and then so you can test it later when you have to walk them all. You keep track of how many there are matching in the rows and the cols. Boom, 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 boom. And I can do the same here because I need to do if col num is 0, do board dot row match count. I need to do this in a bit because I need to switch types. So that's it, right? Oh yeah, and then we have the lookup. Public dictionary lookup set. I can just keep the same naming scheme. Okay. So we can call this actually a new board. We don't need to, we can just do it like this. Now it matches the type. All right, col is new blah. So that's there. Okay, so that is good. Can make this public constants here. Let's see. So that is fine. Bum, ba-dum, bum, bum. This becomes yeah, and this will be col board dot row match count, row num is 0. Okay, so that is that, and now we can say board dot row match count index dot row plus equals 1. We can actually check. Can we do this? Yes, and we can check if row count. Bingo. Boom, 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 boom. So that is that. Else, let's see. Do we need to update the? Yeah, we need to do that anyways. But if board.call match count index.call board.call count bingo. And this will be an else if, because bingo is bingo and we don't care. And we need to update this mapping of the matches. So we always need to set this matches thing. So we do board.matches and we do row, how do I call it? Index.row. Actually, I can just put in index here because it's the same type. True. I need to initialize this to false as well. So I can do board matches. So this is row num col num. It's false. So that is initialized. So that sets up everything. Here we keep track of everything. And here we have our bingo checker. So if we have bingo, void bingo, and then we do board. Let's just do that here. And we do break. We need to break everything. We can just return here, but let's just bool bingo is false. Bingo is true. Come on, bingo is true. And then we can do if bingo break. And we can do the same in this loop. And we say if not bingo, console.writeLine didn't find bingo, sad face. Okay, now if we have bingo, we need to, let's see, what did we do again? We need the sum of all the unmarked numbers on the board, multiply it by the sum of the number that was just called. Okay, so int trigger. So the number that triggered the bingo was a val. So now we do board dot rows. We do the same loop, right? For int row num is 0. Great, now you can do my job. And thank you, Giselle. What do you mean, Z? Now you can do my job. Haven't you done the advent of code yet? Let's see, row num is 0. Row num smaller than board. Actually, just do board.rows.count row num. Do the same for the call. Row is board.rows row num. Let's see. Row.count. Right. Let's do int sum unmarked is 0. And now we can do if not board dot matches. Let's see, row num col num. Actually, this is index base and it should always be filled, so this is always filled. So if this is not, we do sum unmarked plus equals the value of that So we do call and a row call num. Well, my job is basically making bingo games, so slightly more to it, but hey, cool. I actually recently I saw something really cool. Are you familiar with Dave's Garage? That's a dude on YouTube. He's a former Microsoft engineer. And he does really cool videos about software development. And he had a video about winning a jackpot in Vegas. And since there is some law in America that you're not allowed to play anything but bingo, they actually convert a slot machine internally to a bingo card playing game. So when you go into the menu, you can see the bingo cards generated from it. So technically you're playing bingo even though you're playing a slot machine. So that was really fun to see. I didn't know that. So they have like loopholes to work around the laws. So let me see, we're calculating the result here. And I probably over-engineered this solution, but I really like what I made so far. So we'll see how it fares for part 2. So here we add all of those. And then I think we need to sum the numbers for the row, right? Oh no, the last number that was called. So then we do this, and then we do console.writeLine. Okay, sum of unmarked, and then we do sum unmarked, answer, and this will be sum unmarked times trigger. Okay, so that should be part 1, and I wonder if we need to put in the test input for once. I want to see it against the test input for now. So I can do var parts is add, boom. And then we do this same part here. Let's see what happens when I run this. One of the bonus games is a slot machine game which actually bingo in the background. Okay. Format string, not in the correct format. My example here has \r\n. So I need to change my format here to be \r because this is Windows, so I have carriage returns in there. So let's see if I run this now. Object reference not set to an instance of an object. Okay, cool. Matches. That's not initialized. My bad. Okay, let's run this again. 188, 45, 12. I think that was the test input, right? Yeah. Cool, so that works. So let's run it against the real input now. And we have 726 and 25 for 10 as the answer. Submit. Boom! In one try. Nice. So let's see part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo cards a giant squid could play at once, so rather than waste time counting its arms, it's the safe thing to do is to try and figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called. Okay. If you were to keep playing until this point, the second board would have a sum of unmarked. No, okay. Okay, so that is fairly easy. Public bool has one. Okay. So we know the board count here. So we do int board count is boards count. And we do in win count is 0. We can do bingo. We can do board that has one is true. Okay. So now we do win count if win count equals board count. Boom. Okay, let's see. I didn't expect there to be many numbers left, but apparently there are still a lot numbers left. So let's do that. So if win count equals board count, we have. Actually, do I know the board ID here? I don't know which board index it is. It doesn't really matter, but. Actually, I can just do this here. So I can do, yeah, I don't need to keep track of has one. Actually, it helps to keep track of has one because that would mean I can skip it. If board that has one, continue. Let's see, board that has one, bingo, blah, blah, blah. So we only do this, we move this inside, right? It just becomes this. Actually, I could have written this just like, or like that, and just have one if. Okay, so if board has one, sure, if the board count equals that, then we're done, and this will be the last board. Right. Okay. Let's switch back to the test input. I hate having to wait to submit it. Yeah, it's correct. Okay, I don't know why I doubt, but yeah. It feels like I really over-engineered the solution, but yeah, it's robust code that works really well. So, boom, finished it. So yeah, in this case, I think it really was an advantage that I set it up like this. It's very efficient. It has like all sorts of lookups, early exits, etc., etc. So yeah, this was a fun one. It didn't give me as much trouble as yesterday's one. So yeah, I coded part 2 in part 1 here. So I I shouldn't do that, but yeah, it's nice. I like it. I like today's challenge, and I'm glad that it worked out well. So yeah, this was a quickie. Usually the ones in the weekend take a bit longer, but yeah, it worked. So if there's no questions, I think I'll end it here, and see you tomorrow. Right? Well, thanks for stopping by, and I'll see you guys tomorrow. Bye bye.